parent functions are the most basic type of function that you can have. It's where all of our graphs stem from. So lines have a basic function. When we get into our other functions like quadratics, cubics, and square roots, which we will later in this course, they all have a parent function. So everything starts from somewhere, and then we perform the transformations that we were talking about in the previous lesson. So here we have 5 different parent functions that we're going to discuss in this chapter. The first function we have is the constant function. So if you look at the graph, it's just a horizontal line. And if you look at the rule, all that says is this is the equation. Now f of x is the same as saying y equals. So this is really saying y equals c, which is the constant. So it would be y equals 1 or y equals 5. It gives us that horizontal line. We're not going to do much with constant functions since we reviewed them in our first unit, but this is what the rule would be. Our next function is linear, which is what we're going to discuss mainly here in this chapter, and you should be the most familiar with this one, and it is just any kind of straight line. Its basic function is f of x equals x, so it's similar to y equals x. It would have a slope of 1 and a y-intercept of 0. Next we have our quadratic functions. So here in the graph you can see it looks like it is U-shaped. We call that a parabola. We're going to be discussing quadratics in length in chapter 2, but its basic rule is f of x equals x squared. Next we have the cubic function. So it kind of looks like a snake going up the graph, and its basic rule is f of x equals x to the third. The last one we have is our square root function, and I kind of think of this as a hook. It starts at a point and it goes off into one direction, and its rule is f of x equals the square root of x. Now the way that you can distinguish the difference between these 5 different parent functions is by their rules. So square root functions will always have a square root around the x. Quadratic functions will always have an exponent of 2. Linear functions would always have its basic x. So you also can look at its graphs. So all of the graphs will be very similar as well. So when we go into our next slide here, we have just the equations. So you can either graph them in the calculator to figure out what the parent is, or you can just look at the equation. So here in A, I have y equals x plus 2. Well, to figure out the parent function, I really want to concentrate on the x, and here I just have a single x. No exponent, no square root. So that would leave it as being a linear function. Now to figure out what this is doing, I'm going to go into the calculator, and I'm going to graph my function. So to figure out how our first equation is transforming, I've already gone into my calculator and cleared everything out. So when we just want to figure out how the parent function moves, you want to graph the parent function first. So we're going to use one of the rules that we had on our first slide, and it's going to come from what we assumed the parent function to be. And then we'll put the equation that is listed here, that y equals x plus 2 in second. So I'm going to type in my f1, and since I said that it was linear, it's just going to be x. So I have my x in, and I'll hit enter. So on my screen I can see the parent function for a linear equation. Now I'm going to type in the second equation that I was given, the x plus 2, and I'll hit enter as well, and now I have 2 lines. So my x plus 2 is in red, and my parent function is in blue. So I want to figure out what happened from the blue line to the red line. And there's 2 descriptions that could be correct. I could say that the red line moved up 2 units, because you can see looking at the y-axis that from 0 and 0 it moved up 2 spots. Or I could also say that from that 0 and 0 it moved left 2 spots. So you can have one or the other. You do not have to list both. But here, this function either moved up 2 or left 2. Both are going to be correct answers. For part B, I have y equals the quantity of x minus 1 to the third. So I want to concentrate and see what is happening in this function. I see that I have an exponent of 3, so the only parent function that has that exponent would make this a cubic parent function. So like I did in A, I'm going to go into the calculator and figure out the transformation from the parent to the equation here. So for our second function, we said that it was cubic. So I'm going to start off by putting in the parent function for our cubic equation. And the rule is x to the third. So I'm going to hit x, my exponent key, which is to the left of the x squared key, and I'll type in the 3 for my exponent, and I will hit enter. So here in blue, I have my parent function for the cubic function. Now I'm going to type in the equation that was given to me before. So in parentheses, I see that I have x subtract 1, and my exponent is on the outside of those parentheses. So I'm going to close them. I'm going to hit my exponent key again in 3. Now it looks exactly like I have on my paper, so I will hit enter. And now I have my two graphs. So my parent function was the blue, and the one I just put in was the red. So when you're looking at a cubic function, the best place to look is that bending point in the middle. And I can see that it's just shifted over one spot to the right. So we're going to say that this cubic function has just moved right 1. In C, I have y equals the square root of x plus 6. So I know that I see the x under the square root sign, so that's a giveaway that this is going to be our square root function. And same as we've done for the previous, I'll go into the calculator and graph to figure out its transformation. For our third function, we've said that this was a square root function. So I'm going to put in the square root, which you can hit the control and the x2 key to bring up that square root bracket with x underneath. I'm going to hit enter, and that's my parent function for my square root function. Now I'm going to type in the second equation, and that says the square root of x. Now x is the only thing underneath my square root bracket. So when I'm putting this in, I want to get my cursor from underneath the square root sign to the outside. So I'm just going to hit the right arrow, and you'll see the cursor comes out, and then I can type in my plus 6. Okay, so my red graph is going off here on the top, which is fine, but I can at least see what is going on. So from the blue graph where it started to the red graph, I can see that it has just shifted up 6 spaces. So we're going to say that this has gone up 6. And then our last one here, we have y equals x squared subtract 5. So if I look at my x, it has an exponent of 2, and the only parent function that we had the rule of with the exponent of 2 would be a quadratic. And as we've done previously, I'll put this in the calculator to figure out its transformation. Our last function we said was quadratic, so I'm going to type in x squared, and I can just hit the white x key and the x2 button, and that'll give me an automatic exponent of 2. So here I have my basic quadratic parent function. Now I'll type in the second equation, the x squared subtract 5. So remember, the blue was our parent, the red now is my new function, and I can see from the blue to the red it has shifted down 5.